So we're fetching user input. Now it's therefore time to create a struct that will store that data. And I could of course do that here in the main package, but to also practice the usage of packages, I'll create a new package in that project, which I'll name Node, where I'll have a node.go file inside of that node folder. And that will now belong to the node package, so a separate package. In there, we can then create a node struct type like this, and I'm using node with an uppercase N so that we can refer to that struct type from outside this file, so that it's being exported. Then, as a next step, we have to define all the fields that should be stored here in that struct. And for this demo application, that will be a title of type string and the content, which is also of type string. Now we could use title and content with uppercase starting characters if these fields should be accessible from outside this package. But here I actually want to keep them contained in that package and not make them available outside of the package, because I'll instead use methods to allow other packages to interact with that struct. I'll also add one more field, created at, where I'll use the time package, which is part of the standard library and must be imported, and there the time type, which is also a struct, just one defined by the Go developers, to store a timestamp for when this node was created. And with that, we got the node struct. Of course, that's not all I want to do here though. Instead, I also want to create a creation function, a constructor function that builds these node struct instances. That's not a must do, but a common pattern. I'll name it new, since we're inside of a package called node, and it therefore will be clear that when we call a function called new in that package, we'll create a new node. And this function should of course receive the title and the content, which should both be of type string, and it should return a node. Or a pointer to a node if you want to avoid the copy, but as mentioned, for simple data types like this, it's typically preferable to not use a pointer because of the extra overhead that takes place behind the scenes when working with pointers, and therefore I'll just create a node value like this, and I'll return a node instance created with this code. Of course, now we also must populate all the fields of this node struct blueprint though. So we should set the title to the title we're receiving as an argument. We should set the content to the received content and created at to time.now, calling the now function from the time package. And that's therefore our constructor function. However, we could now actually make it more useful by adding the validation code we added here in the main function into this constructor function. Because ultimately, you could argue that it's this node package that should worry about getting correct data for this node. Therefore, I will actually grab this validation logic from my getUserInput function and cut it from there, and instead add it here in this new function in my node.go file. Now here I want to validate the title and check if it's empty, or if the content is empty, in which case I still want to generate such an error. For this, we just need to import the errors package into this file here. And we must make it clear that we're not always returning a node, but sometimes also an error. Of course, here this also wouldn't be a valid fallback value for the node. Instead here, I wanna return an empty node, basically, as a dummy value if we got no valid input. And here, on the other hand, if we do have valid input, I'll return nil for the error. So therefore now, we got this finished new constructor function, which contains validation. And we can therefore now use this constructor function and therefore implicitly this node struct in the main Go file. So here we should start by importing our own package. In my case, the path for my module is example.com/node. So my import path for the node package here is example.com/node for the module path, and then again /node for this package here. So here, after fetching and validating that user input, we can of course start using it here. Now actually, since we outsourced the validation logic into this new function here, we can get rid of it here in getNodeData. We can simplify that. So we can get rid of that here. And the getUserInput function down here will also no longer potentially return an error. So it will just return a string, and therefore its return value should be adjusted here as well. And that then allows us to go back to getNodeData, get rid of the extra error value which we expected before, and will no longer return an error here therefore, instead just 2 strings, so that this function is way simpler now. And with that we can now use this node package and create a new node here after getting the node data, without an error though, by using the node package and now calling this new constructor function, which wants a title and the content, and which then potentially does return an error. But we'll deal with that in a second. First, let's pass the title and content that's fetched by getNodeData to this new constructor function. And then let's store the results we get back, which is that created node, or the user node, that could be a name we want to assign, and potentially an error. Now we are handling the error here, so we should keep that around, but after this if check, we'll know that we don't have an error and that we instead do have a node with this title and content inside of it, and therefore now as a next step, we can make sure that we can then do something with that node. Because at the moment, we can just create it and nothing else. And that's not all I want to be able to do with it.